How a gas pressure regulator works. Episode 1 of the Gas Service Animated Series. Out in the street, gas mains can run at pressures measured in whole pounds per square inch. Far too strong for any home appliance. Your range and water heater are built for a gentle quarter of a PSI. Something between the street and the house has to knock that pressure down and hold it steady, no matter how much gas the home is using. That job belongs to the pressure regulator. Because these pressures are so small, we don't measure them in PSI. We use inches of water column. Picture a U-shaped tube half full of water. Apply gas pressure to one side, and the water rises on the other. 1 PSI would push that water about 27.7 inches. Typical delivery pressure to a home is around 7 inches of water column, roughly a quarter PSI, and a typical appliance manifold runs near 3.5. Here's where the regulator lives, the meter set. Gas rises from the service line to the shutoff valve, your emergency stop. It then enters the service regulator, which drops the pressure before anything else sees it. Notice the vent on the regulator. It must stay open to the atmosphere, screened and pointed down. From the regulator, gas passes through the meter, which measures every cubic foot, then into the house line toward the appliances. Let's cut it open. Gas enters from the street side and must pass through a small opening called the orifice. A valve disc rides against that orifice on a stem. The stem hangs from a flexible rubber diaphragm stretched across the middle of the upper case. Above the diaphragm sits a spring, and the adjustment screw on top sets how hard that spring pushes. Below the diaphragm, the chamber senses downstream pressure, the pressure your appliances actually feel. And the vent lets the top side of the diaphragm breathe as it moves. Now watch it work. 2 forces fight over the diaphragm. The spring pushes down to open the valve, and downstream gas pressure pushes up to close it. Light a burner and demand rises. Downstream pressure starts to dip. The spring wins a little, the valve opens wider, and more gas flows in to replace what's being burned. Shut the burner off and pressure rises, lifting the diaphragm and pulling the valve toward its seat. Thousands of these corrections happen automatically, holding the outlet within a narrow band around its set point, no matter what the house is doing. When every appliance shuts off, flow stops completely. Downstream pressure rises just enough to overcome the spring, and the valve presses fully closed against its seat. The outlet settles slightly above the running set point and holds there. That's lockup, and a regulator that locks up and holds is a healthy regulator. If you're watching a manometer, the needle rises a touch and then stands perfectly still. Now the failure. A speck of debris or a cut disc keeps the valve from sealing. Flow should be 0. But gas keeps slipping past the seat, and downstream pressure climbs and climbs. That's creep, and it can overpressure every appliance in the house. This is why the regulator has relief and why the vent matters. It must be unobstructed, screened against insects, and pointed down. Never plugged, never painted shut. A climbing needle at 0 flow is a red flag. Follow your company's procedures immediately. So on a service call, the regulator gets respect. You verify inlet and outlet pressure with a manometer. You confirm lockup, shut the load off and watch. A small rise then rocks steady. You inspect the vent, screen intact, opening clear, pointed down, terminated properly. And every reading gets checked against the utility specs and your company's procedures. The numbers in this episode are training values, not a substitute for either. The regulator, a spring, a diaphragm, and a valve in perfect argument. Street pressure in, a steady quarter psi out. Lockup is healthy, creep is a warning, and the vent always breathes. Next episode, how the gas meter turns that flow into the numbers on the dial.